And yesterday we were looking at the plate tectonic. We discussed about the continental drift theory and also the plate tectonic theory. Today we'll be able to look at the causes of earth movement. From the previous lesson, we learned that in the continental drift, that as it was put out by Alfred Wegener, we learned that the continents are in constant motion, and they originated from Pangaea, which was said by Alfred Wegener. It was surrounded by one large body mass that was called Panthalassa. And then Pangaea broke into two. That is the Gondwana land and the Laurentian shield during the Precambrian period. In this manner, it was surrounded by a large water body mass that was known as Panthalassa. And then after being splitted into various, the Gondwana land splitted into the northern shield that's referred to as the northern continents. And then the Laurentian shield was broken further into various pieces or various plates that result into the southern continents. And yesterday we were able to mention a number of those continents, and we learned various ways of which they are postulated. Now, we also learned that during the plate tectonic, they are in constant motion, and as a result of that, continents tend to be moving and drifting away from each other, either in all direction, or they are moving towards each other. What were the results? We discovered that they have an effect. One, they cause the earth movement. And yesterday, or in the previous lesson, we mentioned about various movements of the earth. We have the horizontal movement, and we also have the vertical movement. And here, we want also to see how are these movements caused today. That is what we shall be discussing today in our lesson as we move on. One of the causes that have been suggested to have been caused the earth movement is the magma movement within the crust. We have magma movement within the crust. This is believed to have been one of the causes that causes both earth movement, those that is horizontal and vertical movement. There is also another cause that is referred to as the gravitative pressure or the gravitative pull. Gravitative pull is believed to be another cause. And then the third cause is about the convectional currents. Convectional currents. We have convectional currents within the mantle. Convectional current within the mantle, and also isostatic adjustment. These are the various causes that tend to cause the earth movement as they have been advanced by scientists. We find that the magma movement within the crusts trigger also some of the earth movement. We also have the gravitative pull or the gravitative pressure, and then we have the convectional currents within the mantle. Remember, mantle is part of the earth crust. We also have isostatic adjustment. that tend also to cause the earth movement. Let's look at how magma movement within the crust may result into the cause of the earth movement. The rocks in the mantle are believed to have been existing in molten states that is called the magma. Due to the intense heat and pressure that has been generated within the mantle, when fault occurs, when fault line occurs, we have what we call the fault line or the cracks. When fault lines occurs or the cracks occur on the crustal surface of the earth, the rocks in the interior of the earth, that is now magma, will tend to come out, will tend to develop a way of coming out, flowing out forcefully into the earth crust. And there is a space they occupy within the rocks. This space, when it is occupied for a given space, they can be horizontal space or just vertical spaces within the crustal mantle, that will always trigger or will always cause the vertical movement, or sometimes it can cause what we call the lateral movements or the horizontal movement of the earth. I will use a diagram to demonstrate this so that we'll be able to understand much more better. This is an example of just a representation of the layers of the earth crust. These represent the crustal layers. We are looking at the mantle. You see, the earth crust is made up of various layers, and we have a layer that is known as the mantle. When you study carefully the mantle, it is made up of the clastic rocks, and these clastic rocks, a number of them are rigid, but into the inner mantle, when you look into the inner mantle, there is some melted fluid, that is now the magma that we are talking about. The magma that we are talking about, this is where there is a molten fluid or molten rock that is referred to as magma that exists in between the inner mantle and the upper mantle. What happens during this process? When magma tends to move out of this chamber through some crevices or some just cracks, you will find that as it moves out of this, this is what we call magma chamber. In the process that is, as it is moving, it is going to result into the formation of the lateral or maybe the horizontal movement. as the horizontal movement of the earth will be triggered off, be able to see effectively the formation of a certain movement of the earth that is just caused as a result of the magma movement within the crust, and that one is it's acting into the mantle. Now, when you look at this diagram A, this will be diagram B. There is some cracks have developed in the interior of the earth from this is the mantle. This is magma chamber, and then there are some cracks have just begun to develop. Those are crevices, and because there is a force that has been generated by the magma, because it's in molten state, the pressure does not allow it to be confined in the rocks between. Therefore, it will always find an escape. Forcefully, it will come out of this, and then you'll find that if this crack and this one happens, therefore the whole of this magma will forcefully come out and will be ejected into the crustal rocks. These are just layers of the earth, the layers of rocks. These are layers of rocks. Then as a result of that, what will happen? Magma will force itself into various, into a columnar form as it moves out. Therefore, this is the point where it's going to explode, because the cracks have developed here. And then simply this part is going to be very weak, and therefore the explosion will lead into the magma being ejected. The magma is now ejected into the crusts, or into the crustal layers of rocks. Now, it has already ejected out into the layers of the rocks. It has not reached yet on the surface of the earth, but it has caused what we call vertical displacement. And this vertical displacement of rocks is what we call the vertical movement. It has resulted into the vertical movement. Sometimes it may go into a slanting manner or lateral. When it happens in the horizontal or in the bedding planes of the crustal layers, therefore it may result into what we call lateral displacement of rocks, and that one has caused what we call the movement of the earth. Therefore, the crustal rocks, as they have been aligned into the crustal layers, they will be moved. They will be moved by a certain force, and that force, we refer to it as a tectonic force. That tectonic force is the one that has resulted into this movement. We refer to it as tectonic force. Now, when this tectonic force is occurring in between where the magma is forcing itself into the crust, therefore it is going to form a result into a movement that we are discussing about its cause. And this one is the vertical movement of the crustal rocks, has been caused by tectonic force. And as a result of this, what will happen? Because magma is still being forcing itself into the crustal layers, is going to cause some of these crustal rocks to wobble. And as they wobble up, they are going to be uplifted in some regions. And that will be the result of the vertical movement. Therefore, you will find there are some areas of the earth crust, there are hills, some are valleys. It will be the results of the vertical movement. And that one we have already seen. That is how briefly how magma movement within the crust may cause an earth movement that is referred to as the vertical movement. Therefore, in this manner, let's move on and look about the gravitative pressure or the gravitational pull, how it also leads to the formation, how it leads to the movement of the earth. The gravitative pull or gravitational pull we have gravitative pull. Yesterday we looked at gravity also, or in the previous lesson we were able to look at the gravity. And gravity, we said, is a force of attraction that acts in the field of gravity when objects are subjected in the field of operation where the gravitational pull is. Those objects will be acted upon by that force of gravity. Therefore, the earth crust is found in the gravitational field where there is force of gravity. Therefore, the gravitational force of the earth tends to pull bodies toward the center of the earth crust. Now, during volcanic eruption, we'll be able to look at volcanicity or volcanoes in the later lesson. When eruptions occurs, it will leave some voids or some hollow voids that are left, especially in the upper mantle. And that one, those voids, when they are just left empty, there is a gravitational pull or gravitative force that will tend to act on those crustal rocks. When the crustal layers are not very much stable, then they will result into another movement. That is, they may trigger off those rocks to be unstable, and as a result, a movement of the earth may be caused. I will also use some diagram to illustrate that one so that we are able to understand. We'll also look at during volcanic eruption. The crustal rocks may be subjected. The crustal rocks may be subjected to volcanic eruption. And when they are subjected to volcanic eruption, during volcanic eruption, when the magma is trying to force itself into the upper chambers of the crusts, it may result into another movement. It may trigger off a movement of the earth. This one represents the crustal layers. We are looking at after eruption, after volcanic eruption, what has happened? There is an empty void because magma was ejected out into the earth crust, and the force was not actually enough to sustain the movement of this magma. And as a result of that, there are some hollow voids that were created. This one become a hollow void. This is a hollow, or it just called a void. When this void has been formed, what will happen? There is gravitational force that is trying to act on these layers. The gravity is working on the layers of the crustal rocks. And if these layers of these layers of the crustal rocks, they are not stable, they are not very much stable, what will happen? This empty space is going to be filled by these upper layers of the earth crust. And what will happen? You will find that you'll be able to find out that this will result into these layers. Now the layers are going to break, or maybe to sink and occupy the empty space that had been left. They are going to occupy the empty space that has been left, and then in the process, a movement will have been triggered. A movement will have been triggered. Now, during this process, you will find that these layers have been triggered to move down in this manner, and therefore the crustal layers have moved and they have occupied this space. Therefore, in the process, there is a movement that has been caused. Therefore, this layer of the crustal rocks of the earth have developed a curvature. That means they have moved down, and it can be vertical, or this is still a vertical movement of the earth, because now the space that had been left here, you see, the force of gravity has worked out, has pushed these crustal rocks, and now they have been moved, causing some of the crustal rocks to strain up and stress up. As a result, if they are very much clastic, they will stretch, and above all, they are going to fill the remaining part. And this, the empty part has now been filled, and in subsequent, this has destabilized the crustal layers of the earth, and therefore it has caused an earth movement to occur. And this is how it is. You will find that the force of gravity, which pulls almost all objects towards the center of the earth, this is a gravitational force that is represented here. This is a gravitational force that is represented here. It has begun to work, and it is always there on the crustal layers. And as a result, therefore, after destabilizing these rocks, and they have been moved down to cover the empty void, or the empty space that had been left vacuum in the absence of magma. Therefore, these crustal rocks have subsided, they have sunk, and as a result, in the process of sinking, they have created a movement of the earth. In the process, that movement can be felt. That movement can be felt in the earth, and what it will result into various parts. Let's move on and look also about the convectional currents within the mantle. The convectional currents within the mantle. How does a convectional current in the mantle, the convectional current in the mantle, how does it result? Now, we have already seen that into the earth crust, the crust of rocks, some of them exist in molten states, that is magma. And when the magma is in the earth crust, they tend to move and generate circular motions toward the earth crust. And these currents may cause a frictional drag on the overlying rocks of Sima, or the crust of rocks, making them to move horizontally. And that one has been generated by a tectonic force. Therefore, it is the one that is going to create a horizontal earth movement. Let's use this illustration. Let's use this illustration as we move and look into it. You'll find that this is a representation of the layers of the earth. This is a representation of the layer of the earth. We are just looking into the mantle, what happens in the mantle. In the mantle, there is a molten fluid. There is a molten fluid that always is found there. And this is a representation of the magma. As magma moves within, it generates what we call convectional currents. And how are these currents generated? These currents could be generated in this way. Therefore, there are some currents have been generated. And in the process, they are going to cause, this is the current. We call it the convectional currents. The convectional currents are trying to be generated from the magma. When this magma generates convectional currents, and then it's going to exert a frictional drag. That friction of frictional force is going to cause the entire rocks that are in molten form to begin moving in a horizontal manner, moving in these currents like. And as it moves into that direction, it has already resulted the crustal rocks to be dragged behind this force, and that will create a lateral force that is called horizontal earth movement. A lateral force has been created, and as a result of that, when this lateral force has been created, that is how it has resulted into. And remember, this now has generated some force. When these forces are going to strike some of the earth crust, especially the seismic focus, can be generated in this manner. And we'll be able to look into them in the next lesson. This is an horizontal movement of the earth that's now going to move in that manner, subjecting these crust of rocks. If they are still clastic rocks of sedimentary rocks, because they are clastic, they are going to have a frictional drag, and eventually they will move. They will move horizontally, and that is what is going to have an effect. And therefore, the effect will be felt on earth crusts in the long run. Lastly, let us look at the isostatic adjustment. The isostatic adjustment. This is how the convectional currents may cause horizontal earth movement. We have been able to see when the magma is in the mantle of the earth crust, this magma generates convectional currents, and the effect of the convectional currents as they are continuing to move into the mantle, they cause what we call frictional drag. They are going to drag some of these rocks horizontally, and in the long run, the speed at which the currents are going to move are going to accelerate a horizontal earth movement. And this is how you can be able to see in this diagram. Let's move on and look at how isostatic adjustments also occur. Isostatic adjustment. This is the fourth cause. Isostatic. The word isostatic comes from the word isostasy. And what does isostasy means? Isostasy is the state of balance between existing lighter, the upper crust, and the lower heavy crust. There are two types of crust when we remember into the continental crust, the structure of the earth. We have the lighter one that is called Cl, and then the heavier one that is called Sigma. All this is the continental crust. The crust of rocks. We have the lighter one and the heavy one. Therefore, the lighter one is always on top of the heavy one. And therefore, the heavy one hosts the lighter, as also it also rests on oceanic crusts. When the continental crust floats on ocean, the crustal rocks that is made up of Sigma and Cl, they are said to be in a state of balance, and that is equilibrium. When all these have been balanced together, we are able to look at it. That is the state of isostasy. And therefore, in the process, there will be some isostatic adjustment. Why? Because the earth crust is prone to weathering. The earth crust is prone to weathering. It is also prone to erosion. You remember that one? When these crustal layers are prone to weathering and erosion, what will happen? They will always try to balance itself isostatically. Therefore, that is the process we refer to it isostatic adjustment. Therefore, when denudation occurs, that is when weathering occurs, it makes the continents to become thinner and lighter, while the debris that are deposited in the ocean increases, and they increase in dense. They become more denser, and that make the Sigma to sink into the mantle. And as a result of that, there will always be an isostatic adjustment across the continent. And therefore, that process helps so much to make the crust to be adjusted. I will use a simple diagram here so that we are able to understand. This represents the earth crust, and we are looking into those areas, especially in the sea. There will be some, in the sea there is water, and as we are able to see into the sea, there is water. This is the land that is bordering the sea. In the process, we will have these regions of the land. During the process of weathering, it is these areas that are weathered down. And as they are weathered down, what will happen? The sediments are going to be deposited into the ocean floor or into the sea floor during the weathering. Therefore, the balance here will occur. This part is going to become heavy and sinks. As it sinks, it displaces these crust rocks, and then they move upward. As they move upward, in that process, they generate what we call isostatic balance into the state of equilibrium. These sediments have already been sedimented down, and then you will find that the ocean or the sea floor has reduced in volume because the floor has been occupied by the debris. These debris are in form of sediments, and as they are going to wear out this part, as they are deposited here, what will going to happen? Therefore, this part is going to sink into the mantle, and as a result of that, the clastic rocks, the young sedimentary rocks, because they are plastic, they are going to be displaced and then move upward. And therefore, in this process, as it sinks, it's going to cause the movement is going to be generated, so that these are going to be expelled out. As they are going to be expelled, displaced in this manner, and therefore they lead to the formation of a movement. This is a vertical movement because it is moving forcefully, therefore generating a vertical force. And as a result of that, you are able to see how this isostatic adjustment try to balance itself in the state of being equilibrium, and therefore obtaining another vertical force that is a cause of an earth movement. And as a result of that, these waves of the forces that are going to act into the crust or layers, they are going to have an effect on earth crust. Now, what are the effect of these forces that we have been looking at? We are able to look at the cause of this earth movement. What is the effect the effect of the earth movement on earth crust, because it's going to result to lead into the formation of various features that we will be able to look. One of the effect is that when we are able to look at the plate tectonic as it was put forward by various scientists, we learned that that a further study of the continental research has brought about new theory of the plate tectonic. And this suggests that the Earth lithosphere is a series of rigid blocks that are called tectonic, as we had looked at it in the previous part. They are separated from one another by various or distinct boundaries, and that is the effect of the movement. One of the effects is that when a plate moves away from each other, when plates moves away from each other, what will happen? When these plates moves away from each other, when these plates moves away from each other, there is a separation boundary. A separation boundary is created. A separation boundary is created. Separation boundary is created. And this separation boundary that is going to be created, we call it extension boundary. Extension boundary. That is an effect. There are various boundaries that are going to be created. One of the boundary is the extension boundary. And this boundary is formed from the interior of the Earth. There is also another boundary that will be created. These have been moved away from each other. But now when they move into each other, when the plates move closer to each other, when plates moves towards each other, let me use towards each other, what is going to happen? The constructive boundary will be formed. Another boundary will be created. Another boundary will be created. And that boundary, we call it constructive boundary. And then lastly, when these plates move towards each other, they are going to create what we call a constructive boundary. And the constructive boundary is involved when plates move towards each other, and in the manner of comprehensions, we'll also be able to look at when these plates also move into each other, especially when the oceanic plate meets a continental mass. An oceanic plate will always slides beneath the continental one and creating what we call a subduction movement. And the subduction movement is going to generate what we call compressional boundary. When the subduction movement is going to be created, in the process, that is, we have been able to look at we have been able to look at when the oceanic plates meet the continental plates, when two plates meets into each other. Suppose this is an oceanic plate and then this is a continental plate. When they move towards and closer to each other, one that is an oceanic plate will always sink, and that is the process of subduction. And in this process, there are subduction movement. These that are sunk has created what we call subduction movement. Especially this happens along the ocean floor. And in the ocean floor, what will happen because of the subduction movement? It is going to generate the earth movement that is going to lead into tsunamis, or perhaps it may lead into ocean earthquakes that may occur there. We'll be able to look at it. For example, let me use a diagram here to illustrate. Let's look at this diagram to illustrate subduction movement. This one is a symbolic representation of an earth crust. We are still dealing with a mantle. This represents the crustal rocks, and then this is a plate that is moving, and this one is also moving. As it is moving, an oceanic plate meets a continental plate. What is going to happen? You will find that because this is an oceanic plate is resting on the mantle may subject some pressure around this point. And in the process, this is a crack, and this is where there is an extension boundary. As this one moves towards away from each other, and then this one is sliding, it's going to create what we call an extension boundary. Extension boundary is created around that area, and it is found here around this region. This is where there is an extension boundary. Now, as this is an oceanic plate is meeting with a continental plate. Therefore, what is going to happen? A crack that has been created around here, this is going to force some magma to come out in the oceanic plate. This is the seafloor. This is the seafloor, and as you look at it, in the process, it's going to create lateral movement, and it's going to create an extension boundary in between here. Therefore, the crack has already been created. Now, from the interior of the earth, the magma will try to force itself towards those boundaries, and then creating what you call volcanoes. It will be able to create volcanoes around the areas, especially in the ocean floor. And this is the formation of an extension boundary. And this boundary has resulted into what we call it's going to result into horizontal displacement, and then the vertical tectonic force is going to act, and then in the seafloor there's going to be a formation of either earthquake, or they are going to lead into the formation of volcanic. An example of such trench or such examples, we have the Java Trench in Indian Ocean. I'll just give some few examples here so that we are able to know. We have the Java Trench. This one is found in Indian. That is in Indian Ocean. I hope when you try to use your atlas, you will locate the Indian Ocean, and then look at also the map of Africa. That is between Philippines plate and African plate. It is found between Philippine, the Philippine plate and African plate. That is how it is, and at a given time, the extension boundary has been created, and if it is in the ocean, it will result into forceful extrusion of magma. Either it can cause what you call tsunamis, landslides, or maybe volcanics, because we'll be able to look at volcanoes in the lesson that is ahead. We'll be able to identify a series of events and how they are formed and how they occur. The last effect is that if the plate of mass past each other, the boundary of conservative is created because there is no any other destructive materials that are around. Therefore, just like a plate, there is a rigid block. There are just two blocks. When these two blocks are combined, be able to find that there's going to be an effect of moving past each other. this block is sliding past each other, and in the result there is going to be a sharing and tearing. As it slides each other, it's going to create what we call a constructive boundary going to be created. And then if these are two plates sliding past each other, what will happen? This is now giving us a symbolic when it meets, especially in the areas where there are some rings of magma. It is a point that may trigger what we call an earthquake or a volcano. Therefore, we have been able to look at the causes of earth movement throughout, and as we have been identifying how this movement of the earth has been caused, it is relatively easier for us to know now the source of all those movements that are happening within the crust have been caused as a result of the tectonic movement, has been caused as a result of the tectonic movement. And when we look into it, I want to sum up by looking at the causes you identify. This is a question now. Identify causes of earth movement. That is where we had looked at, and we have been able to look at when you are asked to identify the causes of this earth movement in relationship to the plate tectonic, and then you are able to identify one of the causes of the earth movement. I had suggested, and we had learned that it is a magma movement within the crust. We have one is magma movement, and then we have been able to see the gravitative pull. That is the gravitative pull. And then also we have been able to look at the convectional currents. Convectional currents in the mantle, and lastly isostatic adjustment. This is what we have outlined and what we have learned in the lesson of the plate tectonic and its effects. The effect is that it is able to cause some various movement of the earth, that is the vertical earth movement and the horizontal earth movements, and these movements are playing a greater role in our plates, that is in the continents, in various continents of the world, as we have been able to look at. Therefore, magma movement is one of the causes of the earth. Then gravitative pull or gravitative force also may cause earth movement. And then convectional currents in the mantle and isostatic adjustment. This is what is we are able to identify as the causes of the earth movement, and we have discussed them in length. And therefore, in the next lesson, we'll be able to look at volcanoes and earthquakes. And to that part, we will continue in the next lesson. Have a good day. Thank you.